Welcome to qnawire.
In this problem, we have to find the tension in a stick that is being whirled around in a circle at two different points. They're given as the hand positions on a clock in the problem, 12 and 6 o'clock, but I've just labeled them 1 and 3 here for clarity. Now, the only thing that we're given is the tension in the stick at position 2. It's 60 newtons. Now, we can use this information and our knowledge about how the centripetal force works to find the tension at the other points as well. Let's look at the free body diagram, specifically at point 2. We can see that the only force pointing towards the center of our motion here is T2 itself. Fg is pointing straight downward and has no effect on the centripetal motion at all. That means that T2 must be equal to Fc. So we have a value for our centripetal force now. Now remember, since the velocity of the object is constant and the radius is constant and its mass is constant as well, that means that the centripetal force is constant everywhere in the circle. Fc is equal to mv squared over r. So no matter where we are on the circle, as long as those values are kept constant, our Fc is going to stay the same. And that's going to be the key to solving this problem. Let's look at our point 1. So we can see from the free body diagram that there are two forces pointing towards the center of our circular motion, T1 and Fg. That means that Fc must be equal to those two forces added together. Now we also know that Fc is equal to 60 newtons. So we have 60 newtons equals Fg plus T1. Now, we know the mass of the object as well. It's 0.2 kilograms. So, if we want to solve for the tension, we can rearrange to say that T1 equals 16N minus Fg, which we can then plug in values for. It's 0.2 times 9.8 meters per second squared, and this over here is going to be equal to kilograms, so that both are in units of newtons. And then we can find that the tension at point 1 must be equal to 14.04 newtons, which we can just round to 14 newtons approximately. And now we've already answered the first part of our problem. Now we're going to use exactly the same approach for our second point that we have to calculate, what I've labeled point 3. All right, so at this point, we can see that our two forces are pointing in opposite directions. The tension is pointing inward toward the center, and the gravitational force is pointing directly outwards. So that means that at this point, our centripetal force is equal to our tension minus our gravitational force at that point. So once again, we can isolate T3 to make it easier to solve for. It's Fc plus mg in this case. Now we can plug in for our centripetal force, 60 newtons, as we figured out when we started the problem. And in this case, we're going to be adding our 0.2 kilograms plus 9.8 meters per second squared. And that is going to give us a value of 17.96, or approximately 18 newtons. And that's our answer to the second part of the problem.